Today I'm going to be showing you guys how to do example 6 from page 574 of chapter 8.7. The problem is to take the limit as x approaches 0 from the right of sine of x to the x power. However, by plugging in 0, we're getting 0 to the 0 power, which is indeterminate. So we're going to try and solve the problem using L'Hopital's rule. The first thing we're going to do is set the limit as x approaches 0 from the right of sine of x to the x power equal to y. And then we're going to continue by taking the ln of both sides. After taking the ln of both sides, one of the properties of logarithm says that we can move the x down from the exponent and put it in front of the ln. Before we're ready to take the derivative of both the top and the bottom, we're going to flip that x down in the denominator by making it 1 over x in order to make it easier when taking the derivative. Now we're ready to take the derivative of both the top and the bottom. The derivative of the ln of sine of x is going to be 1 over the sine of x, and then you're going to multiply the 1 on top by the derivative of sine, which is cosine. And the derivative of 1 over x, we know from our shortcut, is negative 1 over x squared. So we can just go ahead and move that negative x squared to the top because the ln of sine of x was being divided by 1 over x. After getting the derivative and plugging in 0, we're getting 0 over 0, which means we have to go ahead and take the derivative a second time. However, before taking the derivative again, we're going to simplify that cosine x times negative x squared over sine of x to make it a little easier to take the derivative a second time. We know that cosine of x over sine of x is equal to cotangent of x, so we're going to change that to negative cotangent of x times x squared. We also know that cotangent is equal to 1 over tangent, so we're going to go ahead and make it that by doing negative x squared over tangent of x. And now we're ready to take the second derivative. We know that the derivative of x squared is 2x, and that the derivative of tangent is secant squared of x. After plugging in 0 to that, we get negative 0 over 1, which is 0. And because we didn't get 0 over 0, or negative infinity over negative infinity, or positive infinity over positive infinity, we no longer have to continue taking the derivative. However, our answer is not 0. Because we have the ln of both sides, we can take base e to both sides to get the ln on the left to cancel, making y equal e to the 0 power. And we also know that y to the 0 power is equal to 1. So our final answer of the limit as x approaches 0 from the right of sine x to the x power equals 1.